Yes, hello guys, welcome to another episode of THV Tutorials. In today's video, we're going to be looking at operations management. We'll be discussing the third chapter, that's maintenance and reliability decisions, right? So these are our learning objectives. You're going to learn how to improve system reliability. Also, we'll learn how to determine system reliability, mean time between failures, and also distinguish between preventive and breakdown maintenance. Yes. So, to begin, let's talk about the strategic importance of maintenance and reliability, right? Now, the objective of maintenance and reliability is to maintain the capability of a system, right? So, as I'm doing this video right now, the camera, my laptop, all these things are systems that I'm using to operate, right? So how do I maintain the reliability of these systems, or why should I maintain the reliability of these systems? I should do so in order to maintain the capability of the systems, right? So that whenever I want to record a video, my mic, my phone, my lights, and everything is working perfectly. So that's the objective behind maintenance and reliability, right? Now, we have other points here, like make them well maintained, right? To make it more reliable, they have stable process, right? If your equipment are maintained well, then your operations or production processes are going to be smooth or stable, and also enables you to get the optimum utilization, right? That's bringing to efficiency, so you get the best out of your equipment or your systems. Yeah. Now, what are the major causes of failure that could be anticipated in an organization? Now, before we continue, when we say reliability is simply when a system performs well under a specified range of conditions, then it's said to be reliable, right? Now, in the event that a system is unable to perform in its prescribed range of conditions, then that system fails, right? So what are the major causes of failure that could be anticipated in an organization, right? We have the defective individual component design, right? Every system is made up of individual parts, all performing different functions towards the acquisition of a common goal. So one thing that causes failures in an organization is when there are defective individual components. So some of the components that are making up the system are defective. So certain rules are not fulfilled, and that's can ultimately result in system failure. There's also inadequate production and or assembling techniques. There's lack of backups, inadequate user education, lack of preventive maintenance schedules, poor system design, and inadequate testing. These are the major causes of failure that could be anticipated in an organization. We will touch more on some of these along the path, so let's move on. Now, when we talk about reliability and maintenance, what are the tactics to you, right? How do you go about it? For reliability, there are two ways to do that. You can improve individual components, that's one way, and you can also provide redundancy. That's speaking to having backups for the individual components in your system, right? So the first way is just to improve individual components, because the system is made up of individual parts. If all the individual parts are at their best, then the system is going to be more reliable, right? Now, the second way of ensuring reliability in your systems is to provide redundancies for the individual components. So we'll talk more about that down the line as well. Now, maintenance can be done by implementing or improving preventive maintenance. And another way is to increase repair capability or speed, right? Now, reliability, right? So we just, the first part says what? Improving individual components. So that's what we are treating now, right? So we have system reliability, improving individual components. This is the general formula for system reliability. That's RS. RS is the system reliability. And it's giving us R1 times R2 times R3 times Rn, where N is the number of components in the system. Exactly. So if we were to find the system reliability of a system reliability of a system or a team of 5 components, and it will be R1 times R2 times R3 times R4 times R5. Exactly. Now, when you say improving individual components, this is so right here I have an example, but before I did cover this in the video, so just check it out. It's on the channel. Now, or the link will be in the description, so you have access to it there. We've already done that. So we're talking about failure rate, right? That's the product failure rate. And how so? Another the basic unit for measuring reliability is the failure rate. The product failure rate, I think. So one way to measure the reliability of a system is to know the failures, like how the individual components are failing, which ones are failing, that sort of thing. So for the first computation, you have FR as a percentage. That enables you to get the percentage of failures in your system. That's number of failures all over number of units tested times 100%. And the FRN, that's the number of failures per hour, and that's given by the number of failures all over the number of unit hours operating time. So the number of unit hours of operating time is not straightforward. You also have to further compute that and explain it. Let's say you have a company and you sell mobile phones, and you decided to test 100 mobile phones, right? And you tested them for 10 hours. And let's say that 3 out of the 10 failed. Let's say the 3 failed halfway to the 10 hours. In order for you to get your number of unit hours of operating time, you first have to find the total hours, right? The total hours for the test, the total testing hours. So if you are testing 10 mobile phones for 10 hours, then it's going to be 10 times 10, right? Because each phone is being tested for 10 hours. It's going to be 10 times 10, that will be 100, right? And now we say that 3 out of the 10 failed halfway through. Halfway through will be 5 hours. So that 5 hours interval, that would be what? The 3 times 5. Because we want to find out the operating time. So after those 3 failed, we're no longer operating. So you have to remove that or subtract that from the total operating time in order to get the unit hours of operating time, right? Because the 100 hours is the total testing time. So we'll multiply the 3 failures by half of 10 hours, which will be 5 hours. That will give us 15 hours. Yeah. So our number of unit hours of operating time will be 100 minus 15. So 85. So 85 will be our unit hours of operating time. So to get the FRN, it will have been 3/55 hours. That's how we get the FRN, number of failures per hour. And the mean time between failures, or the MTBF, is given by 1 all over the number of failures per hour. This is also covered in another example, so the link will be in the description. Just check it out. It's a work example on a question like this. It's an example, so we skip. Yeah, so this is the question that was solved. So the link is in the description. Now, providing redundancy, right? Now, to increase the reliability of systems, redundancy is added in the form of backup components or parallel parts. Redundancy is provided to ensure that if one component or part fails, the system has recourse to another. So that's what I was mentioning earlier. So what we just talk about everything we've talked about from systems reliability up to this point was about improving individual components. Now this is the second tactic under reliability, which is what? Providing redundancy. So that's when you have your individual components in your system, and you decide to back up each or some of the individual components, so that in the event that one fails, the other will take its place, right? And that increases the reliability of the system. This is also, we've also saw the examples on this, so we won't be talking about it in this video right now, but you can check out the link in the description for this video as well on providing redundancy, work examples, right? So this is the formula. So when you are talking about providing redundancy, the system reliability is given by the probability of the first component working plus and the product of the probability of the second component working and the probability of needing the second component. So the probability of needing the second component can be interpreted as the probability of the first component failing, right? So we have the probability of the first component working over here. So to get the probability of needing the second component, that's saying that the probability that the first component will fail. So to get the probability that the first component will fail will be 1 minus the probability of the first component working. I know that sounds like a whole lot, so just check out the video and it's going to be broken down thoroughly. Now this is also another example. So this is what I'm talking about here. This is a series connection, right? And you have R1, R2, R3. So this is the initial system. 0.90 reliability, 0.80, 0.99, right? Now R1 was backed up, or a redundancy was provided for R1. So you have 0.9 as well. So when this fails, this will also take place. Same goes for this. But R3 was not giving a backup. So as I said, we will solve all this in the examples to come. Now this is just an example of the parallel redundancy, right? If you remember, when we go over here, we said out to increase the reliability of systems, redundancy is added in the form of backup components or parallel parts, right? And then redundancy is provided to ensure that if one component or part fails, the system has recourse to another. So the main point here is the form of backup components or parallel parts. Exactly. So these are the parallel parts that we're talking about. We have R1, R2, and R3 making one part, and R4. We'll just check the video in the description for explanation on how to solve questions on parallel on redundancy or parallel redundancy. We'll talk about all those things. Yeah, so now maintenance. So as we discussed earlier, there are two types, main types. You have the preventive maintenance and the breakdown maintenance. The preventive maintenance It involves routine inspection and servicing to keep facilities in good repair, right? So that's routine inspections. So let's say every 2 weeks you have maintenance checks on your systems, your equipment, your facilities. Basically anything that you use in your production, right? Now for the breakdown maintenance, that's fixing things as they break down or as they get spoiled. So you can say that preventive maintenance is proactive, whereas breakdown maintenance is reactive, right? So more information on the two. Preventive maintenance is a plan that involves routine inspections, servicing, and keeping facilities in good repair to prevent failure, right? You are trying to prevent failure, and you are doing that by you're trying to prevent failure by having routine inspections, and servicing your facilities, right? And keep them in good condition. For the breakdown maintenance is remedial, right? It's remedial maintenance that occurs when equipment fails and must be repaired on an emergency or priority basis. So this have also been solved in a video. So when we're talking about this, the link will be in the description. Yes. Now, aside preventive maintenance and breakdown maintenance, there is also aside preventive and breakdown maintenance, there's also predictive maintenance, and that involves using advanced technology to monitor equipment and prevent failures. Right? That involves using advanced technology to monitor equipment and predict failures. Right? So without using technology to detect and predict imminent equipment failure, visual inspection and or scheduled measurements of vibration, temperature, oil and water quality. Measurements are compared to a healthy baseline. Equipment that is trending towards failure can be scheduled for repair, right? So this one is we are predicting the equipment that are near the point of failure, and then you do something about it, right? With preventive maintenance, you don't have a strategy for singling out the ones that need repair. You just go all out. Every 2 weeks when we come, we service everything, we inspect everything, right? That's preventive maintenance. But reactive is more selective, it's discriminate. Exactly. Now they are comparing the strategies, looking at their advantages, their disadvantages, and the resources of technology required, right? So the first, you have a breakdown. The advantage is that no prior work is required, right? Because you're only fixing your equipment as they break down, in an emergency or priority, in this kind of fashion. But unlike preventive maintenance, the work can be scheduled, right? So you plan it, maybe if it's 2 weeks, if it's every 2 weeks, whether it's a monthly interval, it's planned, it can be scheduled, right? Unlike breakdown cannot be scheduled because there is no prior work prepared before. Something has to happen before you react. Now, predictive maintenance involves impending failures that can be detected and work scheduled, right? So the advantage of predictive maintenance is that impending failures, right? Equipments that are on the verge of failing can be detected, right? And the work can be scheduled. What are the disadvantages? For breakdown maintenance, one disadvantage is that there is disruption of production, injury, or death. right? Because it happens all of a sudden. You don't know what will happen when one of your equipment fails. It could result in the disruption of your production. That's if you are lucky, right? But it might also cause injury or even kill one of your workers. So that's a really big disadvantage. Now, for preventive, the disadvantage is that labor cost may replace healthy components. Labor cost may replace healthy components. Also, in the predictive maintenance strategy, the disadvantage is that labor cost for detection equipment and services. So with preventive maintenance, it's just saying that you have to have routine inspections and servicing to your operations, and that is going to cost money, right? So that money could be spent on another thing for your business, for whatever, but it just becomes labor cost because you are paying people to do the maintenance. It's not for free. And the same goes for predictive maintenance as well. And that one does not just include labor cost, but it comes with the cost for detecting the equipment that are about to fail, and also servicing them as well. So that involves even more cost, right? But it depends, because when your products fail out there in the world, it can cost you way more money to make things right. So what are the resources or technology required for breakdown maintenance? You may need labor or parts at all hours, because you cannot predict the time your equipment are going to break down. So that's what the odd hours is pointing out over here. Here. But for preventive maintenance, you need to obtain labor or parts for repairs. So I guess that's more constant in a way. You just have to obtain the labor or the parts that you need for your repairs. For the predictive maintenance, you need vibration technologies, infrared analysis equipment, or purchase services, right? And the last column is just application example. So for the breakdown maintenance, you can just implement that for office copiers, photocopy machines and stuff. But for the preventive maintenance, you can apply that on the relamping of your plant or your machine lubrication. And for the predictive, you have to do vibration and oil analysis of a large gearbox, whatever that is. Now, predictive maintenance and effective reliability, right? So what is effective reliability? Effective reliability, RF, right here, is an extension of reliability that includes the probability of failure times the probability of not detecting imminent failure. Having the ability to detect imminent failure allows us to plan maintenance for the components in failure mode, thus avoiding the cost of an unplanned breakdown, right? So having the ability to detect imminent failures allows us to plan for maintenance, right? If we know the equipment that are about to get spoiled, then obviously we can have a well laid out plan, to maintain those components, and it prevents the cost of an unplanned breakdown. So this is the formula, right? So RF is equal to 1 minus the probability of failing or the probability of failure times the probability of not detecting failure. So yes, here is an example. A large gearbox with a reliability of 0.90 has vibration transducers installed for vibration monitoring. The probability of early detection of a failure is 0.7. What is effective reliability of the gearbox? Right. So over here in the question, it's already given us that the probability of early detection of a failure is 0.7. But I'm looking for the probability of not detecting. Right. Remember, probability is always equal to 1. So if you're looking for if you have the probability of detecting the failure, then 1 minus that probability will give us the probability of not detecting the failure. Right. So that's why I'm saying 0.3 over here, right? And they also give us the probability of the reliability of the transducer, right? So to get the probability of the reliability is the probability that it will work. So again, to get the probability that it will fail will be 1 minus the reliability or the probability of it working. It will have been 1 minus 0.9. That's why we are seeing 0.10 times 0.3, right? And that gives 97. Feel free to convert your answer to percentage multiplied by 100. So what I said about the vibration monitoring has increased the effective reliability from 0.9 to 9.7. Right, now increasing repair capabilities. So this speaks to how can you increase the capabilities, for maintenance crew, or the capability of the maintenance crew that to have well-trained personnel, adequate resources, proper application of the 3 maintenance strategies, and 4 is continual improvements to improve equipment or system reliability. Right. So you need to say that one advice being given is to properly apply the 3 maintenance strategies. So this should clearly tell you that you don't choose one and say, oh, in my firm you are using this one and you are using preventive maintenance, so together with the rest. You analyze everything and you realize the ones that it will be useful to implement breakdown maintenance, the ones that will need preventive maintenance, the ones that will need preventive maintenance. Right? That's how you do business. Yeah, that's it for this video. Thank you very much for watching. Please don't forget to like and subscribe. Also, the calculations, the workings of the maintenance and reliability, and the link below. Please don't forget to like and subscribe. Thank you very much.